अगर मैं थोड़ा सा रिव्यू करूं तो लास्ट टाइम वी स्टडीड द method of flow measurement in open channel. याद है? Before holidays we we were studying flow measurement in channels, and in one part we studied the stage measurement equipments, and in the later part we studied the velocity or discharge measurement methods. So one of the most commonly used method was described discharge measurement using current meter, and two kinds of current meter were introduced to you: propeller kind of current meter and cup type of current meter. Pegme. One was a Pegme current meter, I think. Or price. One was price current meter also. And we introduced to you, if you are using current meter, then what is the method to find the total discharge in a channel. We have to divide it into small sections, vertical sections, small strips, and then we have to measure the velocity using current meter in each strip, multiplying it with the flow area. We get the discharge of that strip. Total sum of all the discharges gives us the discharge of the whole stream. Similarly, other methods were introduced to you. So in continuation, keeping in mind we are in the subject of hydrology, and one of the main duty of the hydrologist is to estimate the availability of water on the surface and under the ground of availability of water. We have to ascertain, we have to calculate. So in line we are studying these things. In tandem, in series, we are studying all these things. You were introduced about hydrological cycle and then different components of hydrological cycle. One of the important component, but quite complex component, is the runoff. And it is a component, it is made of a number of different runoffs coming from different sources. So end result of the runoff is the flow in the channel from the whole catchment when flow is collected, and it moves over the land, it moves under the land, under the ground, and then finally it reaches to the channels. So that component we have to study. The right way or the correct way or the most accurate way of estimating the quantity of the runoff coming out of an area, coming out of a catchment, the correct or more accurate way is to measure the discharge in the channel. That we have studied already, how to measure discharge in the channel. Current meter method is one of the method. We can install some instrument also in the channel, like flumes we can install. Depth in the flume can also give us the, we can install weirs, we can have the gated weirs or spillways. That can give us the discharge. That is more accurate method. But sometimes we don't have such facilities and we have to estimate the runoff. Then some empirical formulas are available to estimate the runoff in different kind of the areas. So today lecture will tell us what is the runoff, what it is made of, what are the parts of the runoff, and then in the later part of the lecture, different methods to estimate the runoff. As you know that we can estimate the flow in the channel in the units of discharge, cubic meter per second. Normally we do it like that. And the total volume which is passing from that channel in a certain area, let us say over a year, we multiply that discharge with the time and we get total volume. So that volume, if I divide it over the whole area from where that is generated, that flow is generated, whole catchment area, if I divide that volume over the whole area, I get the depth units. So runoff is sometimes mentioned through discharge unit, cubic meter per second. Sometimes it is mentioned through volume unit. The total runoff in 1 month is so much. So that will be cubic meter volume units or kilometer cube. Sometimes we mention it in depth unit. That is the volume divided by the area from where it is generated. So these are some background. It is quite important. It is related to hydrology because we want to know availability of water at different places, and why we want to know that you are well aware, because we want to utilize it for the beneficial purpose for the humankind. We want to develop some structures so that that water can be utilized, or we want to protect environment, or we want to manage it in a better way. So different purpose can force us that we should know the quantity of the runoff or quantity of the flow at certain places. So in this figure, if you see this figure, you are seeing a channel. At the background is the part of the catchment area, not complete catchment area, which is feeding this channel. Maybe in upper parts which we are not able to see, there are some glaciers also. There are some snowfall, snow-covered mountains also. So that is also feeding this channel. And we are seeing some sheet flow kind of thing over here, flow over the land surface. So this is channel flow. We call this is channel flow. When the depth of the flow becomes measurable in a stream, we say this is channel flow. When it is more like distributed or spread outflow and its depth is very small as compared to its width, we say this is surface flows. We say this is surface runoff, flow over the surface of the catchment. So when this surface flow combined together, it makes small channels. We call them rivulets. When small rivulets join together, we say this is a small channel. When small channels join together, we say this is a river or drain or something. So that is how water is collected naturally, and always water flow in the direction of gravity, downslope. It will always flow downslope under the on the surface of the earth. It will flow downslope. it can come out of the ground. In case of the groundwater, sometimes we have the pressurized springs. So, but that is because of the higher pressure at some place in the aquifer. Aquifer is the soil layer containing water under the ground. Aquifer, you see this word, you will use this word in groundwater hydrology. One part of the hydrology is the groundwater hydrology. So in groundwater, sometimes we have the flow against the gravity, but on the surface, always we have the flow uh, uh, towards the downslope or downhill. From higher elevation, it will go to the lower elevation. So that's why you see in Pakistan, because higher elevation is in the north, so flow is more or less coming from the north going towards south. But there are countries in which flows moves from south towards north. I can give you example of Nile River. So higher elevation is towards the south in Egypt, in Sudan, in Ethiopia. So higher elevation is in the map. If you see, usually maps are oriented north-south. North is up. So if you see in the map, the bottom side is higher elevation and the flow is going towards north. So that is how water flows using the force of the gravity, and that force of gravity is available because of the different elevation. If all the ground was at the same elevation, if all the ground was plain, we will not be seeing such channels, such flows on the ground. So runoff is a proper definition for it. You can see different kind of definitions for runoff. So before I move further ahead, if you have any questions from the previous lectures, so that's important part. If you have gone through those lectures, and if there is some comment, some suggestions about the previous lecture, you are welcome to ask. At the moment, 30 students are with me, 29 students and one myself are with me. That's good in this cool winter day. यहाँ पे कोई सूरज नहीं निकला हुआ, बादल ही बादल है. Hopefully you have a nice January morning. Any questions from the previous lecture? All are sleeping, are doing breakfast, or what you're doing? How many of you are with me? No response. FK
Yes, sir.
अच्छा ये है राजीव रा, one student. FK 170704. Who is it? Okay, I start the recording. So those who are not available, hopefully they will study it at their own. So starting today's lecture about runoff, I have given you already the introduction of what is runoff and now its proper definition. It's that part of the precipitation or snow melt or irrigation water that appears in uncontrolled surface streams or rivers or drains or sewers. So that water which reaches to the streams, that reaches to the stream either from precipitation or from snow melt. That is also snow is precipitation. Snow melt is later phenomena of hydrology. So first snow occurs, immediately it does not melt. So when temperature rises, then it melts, and usually snow melts within the year. So if snow is permanent over there, then we say this is glacier. Then we say this is permanent ice over there. So one is glacier melt, one is snow melt. Differentiate between these two. Both have a different rate of melting. Snow melting is relatively quicker. Ice melting, it takes time because it's more solid, more permanently located over there. So glacier melt, we carry out modeling in a separate way. We have the software available who can give us how the precipitation, how much precipitation will be reaching to the stream in the form of the runoff. We so we say rainfall runoff models. We say such models as rainfall runoff models. We have models who are capable of converting snow into runoff. So what will be the different way of handling them? क्या फर्क क्या पड़ेगा दोनों में? If you are the modeler, if you are making some equation or some computer program, what do you think? How precipitation conversion into runoff is different from snow conversion into runoff? फर्क क्या पड़ेगा? वॉल्यूम में फर्क पड़ेगा या टाइम में फर्क पड़ेगा या किस चीज में फर्क पड़ेगा? हाँ जी, snow melt के लिए that takes longer time, and the second thing is snow melt will be dependent upon the temperature of that place. Precipitation में मुझे temperature का data देने की जरूरत नहीं है. If I want to convert, if I have the data of precipitation, 1 inch of the precipitation in 1 hour, so then only the gravity and infiltration and evaporation will control how much will be the runoff. Whatever the precipitation comes on the surface of the earth, it either goes infiltrated or it is evaporated or it is stored in some depression. And if there is excess precipitation, then it starts running as a runoff and reaches to the streams. So I don't have to take care of precipitation as far as runoff is concerned in case of precipitation, except for evaporation estimation, temperature is required. But in case of snow melt or in case of the glacier melt, temperature plays important role. So in case of precipitation, rainfall runoff models, temperature is not much important if I have the evaporation values available. While in case of the snow melt and ice melt models, we have some models which are capable of doing this kind of conversion. So we need temperature data at that place. If temperature rises above the melting point. Then we say, okay, now this is converted to water. Now start runoff or infiltration or other phenomena should be calculated. So simply runoff is all that water, all that part of water out of the precipitation, snow melt, ice melt, and leftover water of the irrigation. So when we carry out irrigation in a certain area, so not all part is evaporated from that place. Some part reaches to the drains also or rivers also. So that also make runoff. So that part of precipitation, snow melt, or irrigation water that reaches to the streams, that reaches to the rivers, that reaches. So stream, rivers, drains, sewers, hydrologically they are similar. Streams are usually small, rivers are the big streams. Rivers are the big streams. Drains and rivers are a little bit hydraulically they are same. They are open channel. Drains usually have low quality water. They carry out sewage water, especially urban drains. Got it? So drains and sewers, they are carrying sewage water. Sewage water are low quality water, but hydraulically they are similar. So difference between rivers and drains will be, for me, it will be the quality difference. Usually in the natural streams, natural rivers, we say they carry fresh water because they are carrying water from the precipitation, from the snow melt. But usually drains, which are especially man-made drains in the urban environment, they carry low quality water. So another definition is for the runoff can be, it is the flow collected from a drainage basin. Now you know basin and watershed. Got it? Watershed or basin is that area, watershed area or basin is that area which collects water, which provides water, which supplies water at a certain outlet, at a certain place of the channel. So all that area which is contributing water, so we say this is the basin or watershed, or sometimes we call it और क्या नाम है watershed basin और क्या नाम हम यूज करते हैं एक और नाम भी यूज करते हैं catchment area. So that is the catchment area. So ये हम यूज करते हैं नाम. So all that area. Opposite to this is another concept, we say command area. Anybody have idea what is command area? ये catchment area से बिल्कुल different होता है. Catchment area is all that area lying on the upper side usually which contribute water. Command area क्या होता है? Usually we use it. Tarbela command area is this district. Mangla command area is this district. Command area for Lahore branch canal is this area. So अब कुछ idea आया command area क्या होता है? So command area is with reference to canals or with reference to some water supply projects. So all that area which is fed by a structure, which is provided water by a structure or by a canal. So all that area which is provided. So if I provide water, if this Lahore canal is providing water to the Lahore district, Sheikhupura district, and let us say Shadra area, we say this is a command area of Lahore branch. If Tarbela is providing water, or Mangla is providing water to Jhelum and what we call Sargodha and Shorecourt and these Jhang area, so then we say that is a command area. So these are two opposite things. Don't mix catchment area with the command. Reason I am talking about it is, in last week there was a viva of MSc. A student of MSc was not able to differentiate between these two, and we consider this is very basic thing. You should be knowing it. So difference between watershed area and the command area. Watershed contribute water at a certain place, while command area is that which is commanded by that location, which is provided water by a certain structure. Okay, so all that water, one definition of runoff is flow collected from a drainage basin, appearing at the outlet of the basin or catchment. So basin, catchment, watershed, these are the nearly same words, very minute difference. Basin is usually that catchment area which is connected with certain permanent water body like sea or big reservoir. So that we call as a basin. Although it is a watershed, it is all that area which is contributing water, but the outlet of that is at the sea or some big water body. Okay, so all that water which is collected from a drainage basin, so that is also called as the runoff. So it constitute different components. The runoff constitute different parts. The water which constitutes stream flow may reach the stream through different ways. So here we are showing you different ways of making the runoff, or different ways in which the water reaches to the streams and becomes runoff of that command area of that area. So if you consider the precipitation phenomena, it occurs over the land. It also occurs over the ocean also. Now we are talking about only precipitation over the land, because we want to discuss the runoff, and runoff is in the channels over the surface. So we don't have channel in ocean. So that precipitation we are not discussing. So precipitation occur over the land in the form of rain, in the form of snow, in the form of hailstorm, different ways of precipitation you are familiar with. So it occurs over the land. So going through different processes, for example, some part is intercepted by the trees, vegetation interception, we call it, interception by the trees, leaves. Some part reaches to the ground surface. Out of that part which reaches to the ground, and this canopy interception or vegetation interception, that also either evaporate back or it comes to the ground. It does not stay over there all the time. After a delayed time, after small interval, it either evaporates back or goes to the ground. Okay. So when water reaches, or precipitation reaches to the ground, what happens to it? There are three possibilities that will happen to the water reaches to the ground. Either it will evaporate back, or if there is a small depression, it will be stored over there and it will infiltrate. So these three things. So the rest over water that look around and he sees where is the downward slope, downhill slope. So then the extra water which is left over from the evaporation and the infiltration, so that start flowing over the surface of the ground. So immediately it does not make the channel flow. Initially it is sheet flow. It is flow in the form of the thin sheet of water. So after moving a few meters or few hundred meters, then this sheet flow join together and make small rivulets, small channel, very small channels. And then, as I told you earlier, those small rivulets join together and make streams, and the streams joins together to make the drains, rivers, and mighty rivers like Indus River. So that is what happens. So either the stream will be getting water from the sheet flow or the surface flow, or it will be getting water by the direct precipitation on the stream. Streams are in the over the land surface, so some streams, but that is small amount. It gets a direct precipitation, or some groundwater also moves downhill. So here we are showing you the water table line. Here we are showing you the ground surface line, grassy land or ground. So underneath, a few meter, a few feet below the ground surface, usually we have the groundwater surface, and we call it water table. Between these two things, ground surface and the water table, we have the soil layer, which is not fully saturated. Fully saturated means not all pores in the soils are filled with water. So we call this part as the unsaturated zone. And below the water table, we have the soil layers, but all the pores of the soil are filled with the water. So we say this is a groundwater area. So that we say as unsaturated area. So water flows from both the places. From unsaturated area, water flows towards the stream, towards the downhill, and water flows from the ground surface also. Ground is not stagnant. Its flow is slow. It is not as fast as the surface flow. It is a slow flow, but it is flowing towards the gradient. Gradient means slope of the water table line. Slope of the water table line is the gradient. So it is moving towards the gradient. Wherever there is a low water table, it moves towards that. Sometime this water table lines joins with the ground surface line. So over there we see springs coming out of the water. चश्मा जिसको कहते हैं वो बाहर निकलते हुए नजर आते हैं. So that is actually the groundwater table is visible at the ground surface level. So then we see the springs over there. So that also ultimately reaches to the stream. So either you will be seeing springs or the groundwater coming to the channels, or the surface runoff coming to the channel, or direct precipitation coming to the channel, and then channel will move ahead and it will further continuing the collection of the water. And so these are the components of the runoff in the channel. One is the surface runoff, one is the water from the ground, and one is the water from the soil which is unsaturated. So, and one is a direct precipitation. So that is what is mentioned over here. The components of the surface runoff, components of the runoff. So runoff is the combined, everything combined together. So it is made of, number one thing is precipitation that directly fall on the stream. If this is stream, so whatever is coming directly on it, that is component of the runoff. One is from the surface runoff in the form of the overland flow or in the form of the sheet flow. So maybe some area close to the channel, we have the precipitation and the surface runoff reaches directly to the stream. So that is one part. That surface runoff has not yet combined together, and it has not made the shape of the channel. So surface runoff can also, or overland flow can also reach to the channel. This another component is interflow, and this interflow is the name given to that part of the flow which is coming from under the ground but above the water table area. So that is the unsaturated zone of the soil. One different name for this part of the soil, sometimes agriculture people or some groundwater people call this area as Vadose zone, VADOZ, Vadose zone. So you can call this part of the soil as unsaturated soil or Vadose zone. So that part also has some moisture, and that moisture also moves towards the streams in the downhill direction, in the direction of the gradient, in the direction of the downward gradient. So, and the third part is, fourth part is the groundwater flow. Groundwater, if it is at some place higher than the stream, it reaches towards the stream. So it is not always that all these components are present in the runoff. For example, for this stream, maybe groundwater component is 0. There is stream showing over here. The stream water level is higher than the groundwater level. So groundwater cannot reach to this. But if after the monsoon, after the rainy season, groundwater table rises, groundwater is not stagnant. Groundwater is not constant or static. It goes up in after the rainy season and it goes down in the dry season. So groundwater moves up and down depending upon how much is the recharge from the precipitation in the previous months. So if this groundwater is as it is shown over here, it will not be providing any water to the stream. So this component will be 0. But in case of this stream, groundwater is providing some component. And if you have studied hydrograph in the laboratory, and if you have carried out the computation of division or segregation of the component of the hydrograph, so one part of the hydrograph is called as a base flow. So that flow which remains in the channel even if rainfall is not occurring. So this groundwater makes the major component of the base flow. And sometimes base flow consists of groundwaters, and sometimes base flow consists of what we call it snowmelt also. So rainfall is providing us usually water after the rain, and when rain stops, this surface runoff or overland flow that also stop after some time. It takes some time for water to reach from the far lying area of the catchment to the stream. So that we call as, we have a special name for that. हम उसे कहते हैं time of concentration. So how much time water takes to reach from the most far lying area to the outlet, to the location in which we are interested to measure the water. So these are the components of the runoff. So this figure elaborate them. So either water can reach to the stream through from the groundwater bodies or from the unsaturated zone. We call that unsaturated zone water reaching to the runoff as interflow, or it comes from the overland flow or surface runoff. Overland flow or surface runoff. And direct precipitation. So these two components, surface runoff and interflow, they are relatively quicker as compared to, and they are relatively short-lived also. So precipitation occur, these two things will occur. But if precipitation stop for quite longer time, both of them will be vanish away. But this groundwater is more permanent, and it continues even months after the rainfall is not occurring in the catchment, and it is dependent upon the water table level, how much above the stream bed it is. So if it remains above the stream bed, groundwater flow or the base flow will remain in the channel. From here also, I will describe two kinds of streams. One we call as the effluent stream, and one we call as influent stream. So these are the two kinds of streams. We should be knowing about it. Effluent is usually the word we use for outflow. Effluent of a city, or effluent of a water treatment plant. So the water which is going out of that place, so that is called effluent. Over here, this effluent and influent is with respect to the groundwater. So a stream will be called as influent stream if it is recharging the ground, like over here. It is providing water to the ground. Water table is not high, so that water comes from the groundwater to the stream. Rather, stream water is high and it is recharging the ground. So such kind of stream in hydrology is called as influent stream. And that stream which is getting water from the ground, like this one over here, water table is above the bed of the stream. So water will be joined, groundwater will be joined with the stream over here. So this will be called as effluent stream, effluent stream. So keep this definition because in hydrology we use it. And it depends sometimes, depending upon the groundwater table. In one season, one stream is influent stream. In another dry season, it becomes, in dry season, it is influent stream. In wet season, it becomes effluent stream. It is possible. So it depends upon whether it is recharging the groundwater or it is getting water from the ground. So if it is getting water from the ground, we say effluent stream. So same thing, component of the runoff presented in the different way. We have the direct precipitation is one component. Another two components are direct runoff and the base flow. Base flow consists of the most of the time groundwater flow. So those streams which have the base flow available to them throughout the year, so that those are the streams which are running throughout the year. And special name for those streams is perennial stream. With respect to availability of the water over the year, all months of the year, if a stream is having water, without any concern with the availability of the rain or not, if rain is there or not, if a channel has a flow of water all the year, we say this is perennial stream, perennial, running all the year. And if it is having water in some part of the year, and having becomes dry in some part of the year, we call such stream as a non-perennial, sometimes are ephemeral or intermittent streams. So further definition will come in the coming slides. So direct runoff consists of, as it was shown in the previous slide, surface runoff, water coming from the above the surface, and water coming from unsaturated zone. Prompt subsurface flow, quick subsurface flow. It occurs when precipitation occur and the soil layer close to the surface, it gets some excess water, and that excess water moves in the direction of the flow and reaches to the stream. So that is interflow. Uh, if we see each of them separately, what I have described is written over here. Overland flow is that water which travels over the ground surface. Now you are familiar with it. The channel may be any depression which may carry a rivulet of water. Channel in which water flow uh, is sometimes also called as rivulet. And when rivulet means small channel, it is from the river. A small river means rivulet, and these are usually few feet or few inches wide, so they call rivulet. Rivulets are numerous, and the distance water has to travel as surface runoff in some cases is relatively short. So when surface runoff sees a depression, elongated depression, so then it becomes a rivulet. So it is most of the time the surface runoff occurs in a very short length, some few hundred of the feet. And then it ultimately becomes a small rivulets, and then stream, and then big channels, and then rivers. So when it becomes a rivulet, then we say, no, this is not the overland flow. Now this is a channel flow. So now it is carrying a runoff. So therefore, surface runoff soon reaches. So a small length water will flow as a surface runoff, then it will move as a channel runoff, or simply the runoff. So therefore, surface runoff soon reaches a channel, and if it occurs in sufficient quantity, it is an important parameter in forming the peak flood in the channel. So if the surface runoff is in sufficient quantity, then it causes the peaks in the channel flow hydrograph, and usually the flood occurs when surface runoff is joining in the channel. When only base flow is flowing in the channel, then it is the low part of the year. When surface runoff reaches to the channel, then we see the flood peaks, and then we see the high flows in hydrographs, in recorded hydrographs. The amount of the surface runoff may be very small for low rains, and maybe no surface runoff initially. It is not always that all the rains causes surface runoff or reaches to the channel. Not all the rain. Small quantity of the rain sometimes only infiltrate or evaporate. It does not cause surface runoff. So amount of the surface runoff may be very small for low rains, because it has to occur once it overpass the infiltration rate. Infiltration is a seepage. Other name for infiltration is seepage, water going into the soil. So that depends upon the pores, that depends upon the type of the soil. Rocky surface will not have much infiltration. Impermeable surface like roads and like buildings will not have much infiltration. So it depends upon the type of the surface on which rain is falling. So small rainfall sometimes don't reach or don't cause the surface runoff. When small runoff, when it occurs over the permeable soil, the surface, the surface runoff can occur only when rainfall rate exceeds the local infiltration capacity. It's quite understandable that surface runoff will only occur when rainfall rate millimeter per hour or millimeter per day is more than the infiltration rate, that is also described in the similar way, millimeter per day or millimeter per hour or millimeter per second. Depth of water multiplied by the area, that becomes volume per second. So infiltration rate if it is small, and rainfall rate if it is more, then surface runoff will occur. Otherwise surface runoff will not occur. And infiltration rate is not constant. It changes with the soil type, surface type. Sorry. So in many small and moderate storms, surface runoff only occurs from impermeable and saturated areas. Any example of impermeable area? कोई है example आपके ज़हन में? कौन सी surface impermeable होती है? So in case of small rainfall, surface runoff will occur only in case of impermeable surfaces. कोई है surface जो impermeable होती है?
Sir, rock surface.
रोड सरफेस होगी, कंक्रीट की सर्फेसेज होगी, आपके बाहर का स्टील की छतें होती हैं. So that will be the impermeable. Or if that surface is already saturated because of the previous rain or because of some other reason, if it is already saturated, then surface runoff will occur. Extent of such areas is small part of the basin. So these impermeable areas in natural catchment areas are small. As we are urbanizing, as we are making the areas impermeable, so this surface runoff is increasing. So this is quite important topic of current day research. What will be the effect of urbanization on the floods? What will be the effect of urbanization on the flows in the channel? Why they are studying it? Because they know urbanization will convert impermeable areas into convert permeable areas into impermeable area. Previously, it was soil, simply soil placed over there. Now people will construct house, and bulk of that area will be converted into impermeable surfaces. So what will be the effect on hydrology? Precipitation will occur, more surface runoff will occur, infiltration will reduce. What will be effect? It will increase floods level. It will reduce the recharge on the ground. That is happening in Lahore. Most of the area is now covered with the concrete or bitumen or steel surfaces. So most of the precipitation, it reaches to the channels, it enhances the flood peaks, and it does not go into the ground, so recharge is less, so our groundwater is going down. So twice it is affecting this urbanization. So urbanization is necessary, it is required because we need the living places, but it should be carried out in a sustainable way. And the sustainable way we are trying to look for is how much area we should leave as green area, how much area we should cover with the impermeable areas. So that is a good question of research. So LDA have recently given a guideline that 30% area should be left as a green area so that water can infiltrate into the ground. These from here I will tell you maybe some wise in practical life. People ask this: what is the benefit of the grounds in the urban environment? Usually, the ground in a housing society like UET or some other societies, they are kept at the lower elevation, and they have a special name. We call them as a Doongi Ground. The local people will understand Doongi means low elevation. So the rainfall water is collected in that Doongi ground or low-lying ground, and it infiltrates over few days after the rainfall. So that help us maintain the groundwater surface. So if that infiltration is stopped, so groundwater, because we are extracting it for our drinking purpose and industrial purpose, if that recharge is stopped, groundwater will continuously going down, down, down. So one time will come that it will be quite uneconomical or quite expensive to extract the groundwater from the deep layers. That is happening nowadays with Lahore. Approximately 2 to 3 feet per year groundwater is going down, and urbanization is one of the reason. Change of the surface from the soil, bare soil, to the impermeable surfaces. And the second reason for that is over extraction. Population is more, we are pumping more. So we are doing research in this area also, and you people also can continue it. So that is the purpose of the Doongi Ground or low, depressed area in a certain housing society, and that is a necessary thing. Don't try to cover all the society with the concrete surfaces or with the bituminous surfaces. Leave some area for recharge of the groundwater in that. How much it should be, we need to see how much is the effect. So usually LDA say in every house so much area should be kept as the what we call it, unpaved area. Hence, surface runoff is the important part in stream flow. So that is one part of the runoff. Stream flow is runoff. Surface runoff is component of that. So make it sure. So I stop it over here. Similarly, we will describe interflow and then we will be describing the groundwater and then different methods to estimate different factors affecting this thing and then estimation. So we will try to go through this today. 5-minute break. I will join you after 5 minutes. Any questions up till now? So I stop the recording so that recording should be small. You people have got the previous recordings or not? Download हो रही है कि नहीं हो रही? Sleepy. एक ही बंदा है राजीव अरूज राकीब अरूज.
यस सर.
हाँ मैं तुम ही जाग रहे हो, बाकी सारे सो रहे हैं.
पता नहीं सर. बाकी
नहीं सर.
जो नहीं है वो अभी सामने नहीं आ रहा मेरे, ये नहीं अभी मुझे पता नहीं चल रहा. जरा थोड़ा सा बोलो, अपना माइक को ऑन रखो जरा, फिर पता चलेगा मुझे.
यस सर.
हाँ जी अब आया. सी फरहान चौधरी फरहान साहब है.
यस.
वेरी गुड. तो कौन से इलाके में कौन बैठा हुआ है, किसके तरफ सूरज पहुंचा हुआ है इस वक्त? किसकी तरफ सूरज पहुंचा हुआ है? है भाई, किसी की तरफ नहीं है. So you have studied hydrology. कोई बताएगा इस वक्त ये बादल कहां से आ रहे हैं? ये ठंड कहां से आ रही है? दिसंबर जनवरी.
सर ये अल्लाह की तरफ से आ रहे हैं.
अल्लाह ने किस तरफ से भेजी है?
सर नॉर्थ की
तरफ. और नॉर्थ वाले इलाके में किधर से आ रही हैं? पहले नॉर्थ की तरफ आई हैं, फिर वहां से डाइवर्ट होके इधर लाहौर में इधर से ही आई हैं. ठीक कह रहे हो. नॉर्थ वाले इलाके अपर पाकिस्तान जो है वहां पे किधर से आ रही है? इज इट अ मानसून सिस्टम और इट इज अ दूसरा सिस्टम कौन सा होता है? वेस्टर्लीज. ये चीजें याद करो, ये नॉमेनक्लेचर ये आपको आनी चाहिए. So these are the western disturbances which are reaching to Pakistan in these winter days. These are coming from Siberia and such cooler areas. So that's why we are having the low temperature, and that is combined with in December, Earth is so tilted that the northern hemisphere is away from the sun. The axis of the Earth is so tilted that northern hemisphere, the upper north of the Earth, is away from the sun. So we are getting oblique solar radiations, and that's why we are not getting much radiation. So दोनों चीजें combine हो गई हैं. Low radiation combined with the Siberian winds, so we are getting the winter season over here. इस वक्त ऑस्ट्रेलिया में क्या हो रहा होगा? So that is the southern hemisphere. न्यूजीलैंड अभी मैच देखे होंगे.
समर सर.
शायद वहां तो समर है।
समर सर।
वहां तो समर है, और समर की रीजन सोची है कभी क्यों है वहां समर इस वक्त? और वो फेसिंग द सन क्यों है? क्योंकि अर्थ एक्सिस जो है वो टिल्ट हो जाता है इस वक्त. It is tilted in such a way that the northern hemisphere is, if this is the sun, so northern hemisphere, if it is tilted this way, this is sun, so upper part जो है वो दूर चला गया sun से, और lower part southern hemisphere sun के करीब आया हुआ. So that is the reason. So ये हाइड्रोलॉजी को अपनी लाइफ के साथ लिंक करोगे तो मजा आएगा. ओके, 5 मिनट्स के बाद मिलते हैं. थैंक यू. So let me put it on the WhatsApp so that it can be recorded. So go on. So hopefully CR is maintaining the attendance. Of the runoff is interflow, water which is coming from the unsaturated zone of the soil under the ground. So some of the water that infiltrates into the soil surface, it may move laterally. So infiltration is a vertical movement down. So then it start moving laterally, and it will move laterally in the direction of the gravity. Where the elevation is less, it moves that direction. So it starts moving laterally through the upper soils. When they say upper soils layers, they means that part that is unsaturated. And I have described what do we mean by unsaturated means. Not all the pores are fully filled with water. You know, soil is a heterogeneous material, means it has different phases of matter. Soil contains air, soil contains solids, soil contains water. So it is a heterogeneous thing. So if the pores are fully filled with the water, we say this is saturated soil. And if they are partly filled, some moisture is there, some is not there. So we say this is unsaturated zone. So when water infiltrates in the upper layers, so and then it's from the, and it has not reached to the water table. Water table is upper part of the groundwater body. So top of the groundwater body, and we mark that line as the water table where we see soil is fully saturated. Another identification of the water table line is there is no suction pressure over there. The water is at the atmospheric pressure. Above the water table line, the soil has some suction pressure, some negative pressure to attract water. So in the soil above the water table line, if we put some pressure meter to measure the pressure, so it will having some negative side or vacuum pressure like a suction. It will be small amount, but it tries to attract water in that place because it is unsaturated. So below the water table, we have the higher pressure. Same, the pressure rises similar way as the static pressure rises in the tanks. At the water table line, at the top of the groundwater surface, we have the zero pressure. So below that we have positive pressure, above that we have the suction pressure. Okay, so that is how we identify that this is a water table. So if we put some piezometer where we have the same pressure as the atmospheric pressure, we say this is the groundwater table point. So if we have many groundwater table point, we can make a groundwater table surface. Okay, so when water from the precipitation infiltrates into the soil, the top layers are not fully saturated. So if that water moves from that soil laterally and joins the stream, we say this is interflow. This water is called interflow of subsurface strong flow. It moves slower than the surface, but it moves quickly after the rainfall. The proportion of the total runoff that flows as interflow depends on physical feature of the basin. फिजिकल फीचर से क्या मुराद है? इनके एलिवेशन डिफरेंस, सॉइल की पोरोसिटी, सॉइल टाइप. So physical feature of the basin, it is dependent. The proportion of the interflow in total runoff, in the runoff. So that proportion. So that depends upon basin features, and the basin feature is not only limited to the elevation, it depends upon the size of the basin, it depends upon how much is the runoff from the surface, that controlled by the vegetation, that controlled by the depression in the basin. So many physical features of the basin. It depends upon that. A thin soil layer overlying a rock or a flow bed at small depth below the surface, it favors substantial quantities of the interflow. So in which place interflow will be high? In a place where we have a impermeable rock just a few feet below the ground surface. I am talking two things. One is the ground surface, one is the groundwater table line. So below the ground surface, if we have impermeable rock or impermeable surface or hard pan, so such condition will give more interflow. Water will reach to this soil and it will not be allowed to go down into the deep groundwater bodies. So that will move laterally and it gives rise to the higher quantity of the interflows. Uniform permeable soils and the thick permeable soils, like we have the alluvial, we have the plains in Punjab area, thick alluvial soils which are permeable also. So that encourages deeper percolation, that allows water to go to the ground body, to the groundwater body. So that result in less interflow. So in Punjab area, you will see less interflow till there is some clay surface below the ground surface. Then at that place, maybe we have clay is considered as a impermeable layer, relatively impermeable. Silt as compared to loams, clay is considered as impermeable, although it has more porosity. Although traveling very slow as compared to overland flow, it may be huge in quantity, especially in storms of moderate intensity, and hence may be principal factor in the small rises in the streams. Small rises in stream mean rise of the water flow, water quantity in the stream. So it reaches to the stream later than the surface runoff. After the precipitation, first it will be the surface runoff that will be reaching to the stream. So after some time, then interflow also starts joining the stream and start giving rise to the hydrograph in the stream that we can see. So third component or fourth component is the groundwater flow. And the groundwater, I have told you the physics of that if the groundwater surface is higher than the stream, then water flows towards stream also. So when the groundwater increases, groundwater accretion, it means enhancement. Accretion means enhancement. So when groundwater increases or enhance its surface, it eventually discharge into the streams as groundwater. And we have different names for that. We call it base flow. We call it dry weather flow. So this groundwater flow continues even in the no precipitation seasons also. So that's why sometimes people call it dry weather snow or base flow. If the water table intersect the stream or channels, that's what I told you. When water surface is above the stream, it will move towards the stream. And we see this water coming as a spring if water table intersect the groundwater surface. If this is a groundwater surface and this is groundwater table surface, if they intersect, so streams will be visible on the ground. And then they move as a channel flow and then they move. So that is actually making the base flow in the channels. Its contribution, this contribution of the groundwater to stream is called as base flow and does not fluctuate rapidly. It fluctuates, but it does not fluctuate rapidly groundwater surface do fluctuate over the month. If I show you how much is the fluctuation of the groundwater in Junaid Jamshed Stadium, maybe you will be astonished. क्या ख्याल है कोई आपके पास ऐसा knowledge? CEWRE. We are maintaining the groundwater surface groundwater surface levels in Junaid Jamshed Stadium. We have an observation well installed. Let me see who is irrigation, drainage or hydrology lab. इन दोनों में से कोई एक maintain कर रहा है. ये नहीं कर रहे. Hydrology lab. Yeah, you are seeing the this what we should call it. This is a rating curve. This is a hydrograph, or this is what we should call it. On x-axis there is time. On y-axis there is water level. इसको क्या कहना चाहिए? Rating curve कहना चाहिए या hydrograph कहना चाहिए? So hydrograph is a relation between some water property and time. So this is with respect to time, water level. So this is a groundwater level hydrograph. So water level, you see fluctuation 244 point something, 0.5 meter in November 2019. So this is 11th 19. And if we come to the March 2020, start of the corona in Pakistan, so that was the lowest water level 243. तो कितना fluctuate हुआ? चलो यहाँ से नहीं देखते, highest से देखते हैं. Highest it goes in August, जुलाई अगस्त में highest है 245 के आसपास. So this is the water level of the groundwater table. 245, lowest was 243, so 2 meter fluctuation. So groundwater do fluctuate, and but it does not fluctuate as rapidly as the streams fluctuate. So that's why most of the time we don't have much variation in the base flow, but it do vary. Basin having highly permeable size and large effluent groundwater bodies. Now you should be knowing effluent groundwater bodies, those bodies, groundwater bodies which are releasing water. So they show sustained high base flow throughout the years. So we need permeable soil so that water can reach to there and they can release water. Permeable soil gets water easily, permeable soil release water easily. And they should have huge groundwater bodies or aquifer. Groundwater bodies means soil, which are effluent, means they are releasing. So they give sustained high base flow in the channel. Base flow is that part of the flow in the channel which is coming from the ground, which is coming from the groundwater. So they have sustained groundwater throughout the year with the relatively small differences in the stream. So they does not fluctuate rapidly because of its low velocity, and basin having low permeable soil, उसके opposite है, they release less water. So depending upon if the stream has the base flow throughout the year or it has the no base flow, we can divide streams into ephemeral, intermittent, and another one, ये नीचे वाली नजर नहीं आ रही, perennial streams. See what makes them ephemeral or intermittent or perennial. ये perennial आपको नजर नहीं आ रहा, अपनी स्लाइडों में देख लीजिएगा. ये क्यों नहीं सरफेस नजर आ रही? इसको हाइड करना पड़ेगा. कैसे हाइड होता है? टास्क बार. नहीं हाइड हो रहा. अच्छा जी. So, but anyhow, it is written over here as a perennial. See what is making them the different. It is the groundwater surface level. This dash line is the groundwater surface. So in case of ephemeral stream, groundwater surface remains below the channel bed. It does not go above, so it will not be getting base flow anytime. So this stream, ephemeral stream, will flow. It will have water when rainfall occurs. If we see its hydrograph, it will look like this, ephemeral stream. So we will be having the hydrograph peak or hydrograph enhancement, and then it will come to zero. We will having another hydrograph enhancement. We call them pulses of the flow. We will be having a pulse of flow, another pulse of flow. Both will be matching with the precipitation occurrence in that catchment, in that basin. So in some cases, we have the groundwater groundwater body always, groundwater table level always above the stream bed. So groundwater are sufficiently higher, so they are feeding to the channel throughout the year. So their hydrograph will look like this. When there is the rainy season, maybe there is high peak of the hydrograph. When there is no rainy season, it does not seem to be hydrograph of climate of Pakistan. In Pakistan, if you read this, January, J means January, F means February, March. So these are the month of the year. We should have hydrograph higher in the summer months, June, July, August, September. Our hydrograph will be higher over here. So this seems to be some place in Australia maybe. They have the peak summer in the January, February, and December. So their hydrograph do fluctuate in these streams also, and but it does not reaches to zero. Stream continue to flow throughout the year because some groundwater body is feeding it throughout the year, and that groundwater body, groundwater table, remains above the bed of the channel. So it is feeding the channel. So this is a perennial stream. So this one is a perennial stream. This is the ephemeral stream. Some streams fluctuate during the year. So these streams normally they cease flowing for weeks or month each year, but again they start flowing when water table rises above. Then they become like ephemeral, and in the prolonged dry season they becomes like ephemeral stream. So we call them intermittent streams. So that stream which 100% correspond towards the rainfall and no flow at all immediately after the rainfall, we call them ephemeral. And those which are flowing throughout the year, we call them as perennial. And those which have sustained longer period of the dryness in the stream and then sustained longer period of flow in the stream, we call them as intermittent streams. So actual hydrograph of Pakistani river, if we say over here, है कोई पाकिस्तानी river यहाँ पे नहीं. This one is what direct runoff. This is also not Pakistani, but it is in the northern hemisphere. It is in USA. USA is northern hemisphere, Texas. So they are having high flows in June, July. And you see no time in the year it reaches to the zero flow. So it is getting some quantity of the flow, even if there is dry season in the year. So we say that this is the base flow. Water coming in the dry season, we say that is the base flow. So this is again example of the ephemeral stream. This one, this graph. This is again ephemeral river. They are corresponding to the rainfall only. This we call as a snow-fed river. You see, a rain-fed river has sharp peaks, and snow-fed will have relatively smoother, not much fluctuation as the rainfall stream is there. So this is the snow-fed rivers. When the summer season comes, they increase, and slowly they reduce as the winter season comes. They are also having a base flow over here. Okay, factors affecting the runoff. There are different factors which affect the runoff, and we can divide these factors into two kinds. One is factors related to the precipitation characteristics. How long is the precipitation? how much is the rate of the precipitation, what are the direction of the flow of the storm causing precipitation, which kind of precipitation it is, whether it is in the form of liquid like rain or it is in the form of solid like snow and ice. So precipitation characteristics do affect the runoff and some physical characteristics of the basin. So we will see what are these factors. We will name them over here. Maybe we will further describe them in the next lecture over there with the help of the figures. Some of the effect of the factor on hydrograph will be shown. How the shape of the hydrograph. So runoff is expressed in the form of hydrograph. We are saying the water which is reaching to the stream is runoff, and that we described in the form of in the graph. That is the discharge versus time, or water depth versus time, or volume of the water in a month versus time. So in this way, we say that hydrograph is the representation of the runoff in a channel. So type of the precipitation, as I told you, depends. What do we mean by type? Snow or rain? Whether it is a thunderstorm or cyclonic or frontal activities. So these are different kind of the rainfall. Their intensity varies. Thunderstorm and cyclonic activities, they vary from the center of the cyclone. So their intensity changes with respect to the location to location. And if it is a thunderstorm, or if it is a westerly kind of rainfall like it is happening now, so it will be happening over the widespread area at a lower rate of the rainfall. While if it is a cyclonic activity, it will be short duration but may give high rate of the rainfall in case of the cyclones and the frontal rainfall. So intensity of the rainfall, whether it is light or whether it is heavy, duration of the rainfall, whether it is short or longer sustained rainfall, distribution of the storm intensity on the basin area. If we have a large basin, whether the rain is occurring over the whole basin, then different huge volume of the rainfall is expected. If it is large basin but rainfall is occurring at a part of the basin, rest of the basin is dry, then location of that part of the basin is important, whether it is close to the outlet where we are measuring the runoff or it is away from the outlet. So that will change the characteristics of the runoff. Maybe same rain occurring close to the outlet will give peak quickly, and if the rain is away from the outlet, its peak will be coming later on and it will be of lower value, it attenuate. So that also controls the shape of the hydrograph and the quantity and type of the runoff at the outlet. Direction of the storm movement do affect moving away or moving towards the outlet. So that also affect. With the help of the figure, we will be describing it next week. Other climate conditions which affect evaporation and transpiration. Temperature and wind affect to some extent because we say runoff is dependent upon precipitation minus the losses. Losses includes evaporation, losses include infiltration, losses include storage in the channel, storage in the basin. Some physiographic features of the basin, which kind of land use is there? Can you understand land use? For example, we have a land, it can be used for agriculture purpose, it can be used for inhabitation, it can be used for urban dwelling purpose also. So it can be used for forest, it can be used for grazing. So different kind of the land use change the surface runoff, change the infiltration. So that affect the runoff, because land use affect the infiltration, because land use affect the what we call it runoff. If it is a well plowed land, we have cultivated the land, we have plowed it. If rainfall occur, much infiltration will occur. and it will not allow water to flow in as a surface runoff. So as compared to that, if it is a impermeable surface, no infiltration, quick surface runoff. So we can understand that land use is an important parameter which affects the quantity of the water reaching to the stream, that is the runoff. Type of the soil do affect. If the same place we have a sandy area and another place we have the clay area, so their infiltration will be different, their runoff characteristics will be different. At one places we have boulders, at other places we have roads, so its infiltration and the surface runoff characteristics will change, so the total runoff will change. Area of the watershed, how big is the area? If more is the area, more volume will be collected. If less is the area, maybe the volume collected or the peaks will be different as compared to the larger basins, the larger watershed. Elevation means elevation controls the one thing, it controls the temperature in that area. As we go to the higher elevation, temperature reduces. We are expecting more snowfall over there. So that controls the runoff. Another thing, elevation controls the slope of the area also. So if we have higher elevation and the lower elevation lower, so we have the steep slopes over there. So both things are related to the elevation, slope also related and the temperature also related. So when steep slopes are there, surface runoff will be quick and we will be getting quick response of the stream after the rainfall and after the storm activity. We see bashing stream, we see high speed stream in the upper area where slope is quite high, and we see calm runoff in the plain area because slope is less. Orientation of the basin, whether it is very wide or very narrow. So that is the shape of the basin, let us say. Type of the drainage network. If we have the drainage network well developed in the basin, or drainage network is not developed. Drainage network means how many streams are there in a unit area of the land. So if area has well developed drainage network, then it will quickly release the water towards the outlet. If there is no drainage network, like in desert area, drainage network is not well developed, so that will not give much runoff to the outlet over there. So these are some of the factors. So we have some formulas available if you cannot measure the runoff. Again, I say good way is to measure the runoff in the stream by the methods told to you already. If we cannot measure the runoff, then we most of the time we have to estimate the runoff, and some formulas have been developed by different researchers, and those formulas can be called as empirical formulas, or they are called as infiltration based formula. Sometimes we say this is a rational, it has some rationality in it, it has some logic in it. So rational formula is there. One unit hydrograph method is quite commonly used, and another method we call SCS method that will be introduced to you. Usually the empirical formulas, they relate runoff with precipitation with some coefficient multiplied with the precipitation. So we say this is a loss coefficient something. So I hope you understand now that runoff is the result of, especially the surface runoff. So that is surface runoff is the result of precipitation event. Although the total runoff is result of the precipitation event plus base flows plus interflows. So usual method are that base flow and interflow, base flow are considered constant in a certain catchment. So usually people don't try to estimate with this formula. People try to estimate only the direct runoff, that is the result of the precipitation event. So they multiply the amount of the precipitation with the coefficient, and that coefficient they develop by seeing the previous behavior of that catchment. Previous month, so much rainfall occurs, so at this place, at this outlet, so much runoff occurred. So they got a coefficient relationship between them. So they have seen from the experiences that this catchment is behaving in this way. So they have developed coefficient for different catchments. So this coefficient is dependent upon the catchment, its size, its shape, on the weather condition over there. So these are called as the empirical method. As I told you, runoff will be represented either by discharge, cubic meter per second, cubic feet per second, or by depth unit or by volume unit. So most of these formula, they describe runoff in terms of depth unit, like centimeter. CM is centimeter over here. So coefficient times rainfall in centimeter, and usually we apply it for a larger time period. So one of such empirical method is English formula, and English was a scientist working in this area of India, Pakistan, for Bombay Deccan catchment. So this is one of the catchment in current day India. So he said that runoff for that catchment at a certain location at Bombay Deccan outlet. So that is precipitation multiplied by a coefficient. So he thought that precipitation minus 17.8 divided by 254 multiplied by the precipitation will give us the runoff in the centimeter units if precipitation is mentioned in centimeter units. Precipitation and runoff both are in centimeter units. So from the observation, he has developed this area. Similarly, we can propose similar formula for Ravi River at Shadra if we have the rainfall in the upper. So usually these are made for the smaller catchment. So for bigger catchment, maybe these formula are not good. So for smaller catchment and those catchment which are uncontrolled catchment. Feel the difference between controlled catchment and uncontrolled. That catchment which has been developed by constructing a reservoir or dam. So downstream of that dam, flow will be controlled flow, which is released by the dam operator. So we cannot use such formula over there. So these formula are for natural basins which don't have the much control over there. So they are flowing depending upon precipitation. Their flow is dependent upon the physiography of the basin, not dependent upon the operator of the dam or some structure. So over there such formula can be utilized. So it can determine precipitation over watershed area when so there is a question that determine the runoff if the precipitation is 23 centimeter. So from this formula, we can see that it cannot be used for precipitation less than 17.8 centimeter in that area. So English thought that runoff will only occur when precipitation is more than 17.8 centimeter. Below that, it will yield negative result. And of course, negative runoff is not possible. Either it will be zero or there will be some runoff. So negative runoff has no concept in case of hydrology. So when precipitation is more than 17.8, then runoff should be computed. Otherwise, say that runoff is zero. So when precipitation is given as 23, put the p-value over here, you will be getting the runoff. So this is empirical formula, good for Bombay Deccan catchments. Lacey developed formula for Ganges plain. He said that runoff is dependent upon precipitation and also the type of the precipitation, durability factor of the precipitation, and the catchment factor S, which is dependent upon the type of the catchment, its slope, and physiographic feature of the. So F take care the precipitation characteristics, and S take care the physiographic. So he's proposed that this is good for Ganges basin catchments. And Ganga has a special features. It is flowing along the Himalaya range. If you see the alignment of the Ganga basin and its tributaries, so it is flowing at the foothill of the Himalaya, moving from the west towards the east towards Bangladesh. and it has special kind of weather condition over there. So we should not blindly use such formula at Indus Basin. We can develop similar formula for these basins also, but their factor may be a little bit different from this 304 or something of 1.5, 0.25 over here. So he said that R is equal to P over 1 plus a factor divided by P into F over S. So these factors F over S are described as if it is a full monsoon developed, if it is a middle of the monsoon period and monsoon is well developed, then F should be taken as 1.5. And if it is a weak monsoon, then it should be taken 0.5. In between, user have to use his judgment that what should be the F value. So if the slope is high, upon the slope and varies from 0.25 for flat slopes and 3.45 for hilly areas. Further, if we want to see how he described flat, how he described hilly area, we have to look into the research published by the Lacey himself. So we have the upper and lower bounds given by the Lacey over here. Determine the runoff in centimeter when mean annual precipitation over watershed is 98 centimeter. Precipitation is given, and we can assume full monsoon and the flat region. When we say full monsoon, F should be taken 1.5 and flat area 0.25. So carry it out and determine the runoff in centimeters. And if I ask you that catchment area is 100 kilometers square, so you should be able to convert it into the volume units. Okay, so you should be said that precipitation of 98 centimeter will give so much volume cubic meter per second. For that, area will have to be informed to you. Lacey method has been further elaborated by other researchers like somebody who did it, Khabat Kasarvi in 2000, 2013, he put this research paper and he described this F over S factor. He used the nomenclature of F over Z. In previous example, this was S. So these are the same thing, S or Z. Some people have represented it with S, some people have represented with Z. So F over Z factor were described by this researcher depending upon the land type and depending upon the type of the precipitation, long, medium, short precipitation, land type, flat plains with deep soils, flat with semi-deep soil, relatively high hills. So type of the soil and slope is described over here. Type of the precipitation described over here. Knowing these two factors, we can find the F over Z value from this table. So suggested coefficient of Lacey method. So these are the F over Z values in this table. So if we know the F over Z value for that catchment, so we can find the runoff in centimeters if the precipitation is given in centimeter. And he says that use this Lacey, the Indian scientist, various water, and he did it for Ganga Basin. He did not, he used the data of the Ganga Basin and then he has proposed this coefficient. Khosla, another scientist of this region, again for Ganga Plains, he has proposed a temperature-based runoff formula that runoff is precipitation minus T over 3.74. He further improved it by saying that runoff is equal to precipitation minus losses, and he said losses can be estimated from the temperature of that place, 0.48 into Tm, depending if it is temperature is more than 4.5 degrees centigrade in that area, use this one, and if it is less than 4.5 degree, then use the table given in the next slide. So if it is less than, then Lm is given directly rather than T, the factor is given, Lm is given directly over here. So we can use this any of these two formulas given by the Khosla, and we can estimate the runoff. So one of the numerical you have to carry out using this Khosla method for different temperatures. Rainfall is given. Runoff you have to estimate. So this is for whole year. For each month you have to calculate it separately and the total runoff we can estimate at the end of the year. For each month we can estimate, and then we can sum them together. One method frequently used is SCS curve number method. I think we don't have time to start it. We will do it next time. And another method is hydrograph, unit hydrograph method. So I stop it over here. We have seen some empirical methods given by Khosla, by Lacey, and by Inglis. All of them multiply precipitation with a certain factor. In some equations, they have tried to make it more rational. They have tried to make it more physics-based by incorporating the physiographical feature of the basin and the precipitation type. So they are moving towards more physics-based formula rather than pure empirical formula. For example, if somebody has given a formula that runoff is 0.5 times precipitation, so that is purely empirical formula. But if somebody have put in the coefficient some parameters which can be measured from the basin, like slope of the basin, soil type of the basin, we say it is moving towards rational or a conceptual formula or physics-based formula. We say such formula as a physical formula. So our effort is continuously moving towards physics-based relationship, which can be repeated, which can be measured from the field. So I stop it over. Please go through it. These are important topics. Enhance your hydrology understanding. If you have questions, you are welcome. Attendance was already taken. CR, please confirm that you are taking the attendances. CR, मुझे कोई जवाब नहीं मिला. CR, please mark attendance. Who is the CR?
Okay, sir.
Okay, sir. Okay. तो मैं आप पे भरोसा कर लेता हूँ. Any question? Stop recording. So if you have no question, I stop the sharing. I stop.